Hello, my name is Vishav, and I built a full stack stock trading simulator that handles real time market data, secure user authentication, and complex financial transactions. I'll provide a comprehensive walkthrough of the entire application, demonstrating how I architected the system and the industry standard coding practices I implemented throughout the development of this full stack stock trading simulator. This application leverages a robust tech stack, including Python Flask for the backend framework, SQLite for efficient data management, and responsive HTML, CSS templates for a clean professional user interface. Firstly, we must register to log into this app. So I will type the username and the password will be HELLO. When entering our password, the password isn't directly saved into the SQL database. Rather, the application uses industry standard Werkzeug security for password hashing and authentication. As we can see from the .db file, the username is VN and the password is actually hashed into this really long script, which is encrypted. So even if the .db file gets leaked, the password will not be compromised. At the top of our application, you'll notice that we imported the Werkzeug security library for password hashing. When we examine the user registration function, you can see that we take input for the user password, and then we actually hash this password, and then we do db.execute to insert this password into the SQL database. Here, we can see the user dashboard with a starting balance of $10,000 in virtual funds. The navigation provides access to all core trading features, such as real-time stock quotes, buying stocks, selling stocks, and the transactions history of all stocks that we have bought and sold. On the right-hand side, we can see the HTML for the quotes page, the HTML for the buy page, and the HTML for the sell page. On the quote page, when we quote a share, the application integrates with a RESTful API using standard HTTP GET requests and URL parameters to fetch simulated market data. The application sends requests to CS50's financial API to get stock data in JSON format, then processes the data to display company names and current prices. I built in error handling to invalid stock symbols, ensuring the app works reliably for users. Although the share prices are simulated, this was a good learning experience for me in integrating RESTful APIs to power my applications. On the right-hand side, we can see the actual RESTful API, which is used to query the current share prices. Now, let's buy 5 shares of Tesla. So here we can see our current holdings with our recently bought 5 shares of Tesla. When we go to sell the shares of Tesla, we can see that we're only allowed to sell shares of stocks that we have bought. So right now it's only Tesla, but if we go and buy, let's say Meta, and we buy 2 shares, so this is our current holdings. And now when we go to sell shares, we can see that we can now also select Meta from the list and sell shares. So let's sell 1 share of Meta. And as we can see, now we only have 1 share of Meta, whereas before we had 2. The transactions that we just made are reflected perfectly in the SQL database. As we can see, for the username VN, the user ID is 1. And when we go to transactions, for the person whose user ID is 1, they made 3 transactions in total. They bought 5 shares of Tesla, they bought 2 shares of Meta, and they sold 1 share of Meta. Looking at the current holdings for VN, we can see that our total value of current holdings is worth $10,001. But every time we refresh our page, the API fetches current market share data, and so therefore our total value of current holdings changes. Now, let's take a very quick look at our Python logic, specifically the buy function. So for the buy function, we make sure the user entered the correct symbol, and then we quote that symbol using the RESTful API, and we get specifically the price. So then we multiply the price by the number of shares that the user wants to buy to give us the total cost. And in order to determine whether the user can afford the total cost of the shares, we query their cash from the database, from SQL, and if the user's total cost is greater than their cash, we tell the user that they cannot afford these number of shares. But if it's not, then we subtract from their cash the total cost of the shares. And we update the SQL database according to their new purchase. I hope you enjoyed this quick demo of my stock trading simulator, and I want to thank you very much for your time.